For our next example, I'm going to introduce the this keyword, which is a special keyword that allows an object of a class to refer to itself. And we're going to use it or demonstrate it in a commonly used manner. Now, for the purpose of this example, we have two classes that are in the same file. We have the class called thisTest, which simply contains main and creates an object of another class called simpletime, which we're going to define down below here. Notice that the class, even though they're defined in the same file, simpletime does not have to be defined in the file before thisTest, and that's because the C# compiler scans through the entire file looking for all of the classes that are defined, and therefore knows that simpletime exists even when it's defined after line 9 in the source code file. So our simpletime object called time is being initialized with 3 different values for the hour, minute, and second respectively, and then we're just going to call console.writeLine and invoke the simpletime class's build string method, which is going to return a string representation of the simpletime object called time. Now, in our simpletime class, you'll see that we've once again declared 3 private integers, hour, minute, and second. We have a constructor for initializing the hour, minute, and second, a build string method to create a formatted string, and then we have a toUniversal string method, which is simply going to give us the hour, minute, and second in separated by colons, with each of them in 2-digit format. Now, if I just run this program quickly, you'll see that we're producing 2 lines of output, one in which we're going to explicitly be using the this reference, and we'll call toUniversal string using it to produce the string that you see here, and one in which we're implicitly going to use the this reference, and we'll talk about both cases as we go through the code here. So let's look at the simpletime class's constructor. Now, the this reference is available to you in all of the non-static methods and properties of your class. So basically, it's associated with the current object of a class that's being manipulated, and it allows the object to refer to its own members. And what we're showing you here on lines 24 through 29 is one of the common ways in which the this reference is often used within a class definition. For this constructor of our class simpletime, we've named the 3 parameters to the constructor exactly the same as we named the instance variables, and many programmers like to implement their constructors this way. I personally prefer to use a shorthand for the hour, minute, and second parameters so that I don't need to do what I'm showing here, but this is a commonly used practice. So in line 26, we have an explicit use of the this reference, and basically what this does is it says I would like to take the instance variable hour. When you say this dot, it goes into the class's set of members and looks for a member of that name. I want to take that instance variable hour and assign it the value of hour, and notice as I hover over hour, it tells me that's the parameter hour. When a parameter has the same name as an instance variable, the parameter, while it's in scope, hides the instance variable. However, you can still get to the instance variable by qualifying it with the this reference. So if I hover over hour in this case, you can see it says int simpletime.hour, and that's to indicate that it's the hour member of class simpletime, and it has the type int. When I hover over the hour on the right side of the assignment, which is not qualified, it assumes that's the parameter that it's receiving at line 24. So this is one way in which the this reference is commonly used within a class, where a parameter has the exact same name as an instance variable, and in one case within the method you want to use the instance variable, in another case you want to use the parameter. So by qualifying with this dot, we're saying let's access the instance variable of the current object that's being initialized with the simpletime constructor. So when I go back up to main here and I say new simpletime and pass in 15, this parameter hour will receive the 15, That will be the value on the right side of the assignment at line 26, and because we're assigning it to this dot hour, the value will be placed into the hour member of the simple time object that was created back at line 9. And you can see we're doing that as well here for the minute and the second instance variables as well. Now, not only can you use the this reference to distinguish between an instance variable and a parameter within a given scope, you can also use the this reference to explicitly invoke the other methods and properties of your class, specifically the non-static other methods and properties of your class. And in fact, every time one non-static method or property invokes another non-static method or property within the same class, the compiler is implicitly using the this reference to make that call. So for example, here at line 35 and 36, you can see that we're creating actually lines 34 through 36, we're creating a formatted string in which we're going to display this .toUniversal string in the first placeholder, and then in the second placeholder we're going to display the result of calling this .toUniversal string, which says go into this object and call its specific toUniversal string method, and for whatever the current simple time object is that's being manipulated, its universal string will then be displayed in the placeholder number 1. Then we're showing the implicit use of this in line 36. When we say toUniversal string, anytime you have a method name by itself being called from within a method of a class, that means you're calling another method of the same class, and implicitly right in front of this call is this dot. The compiler puts it in there for you automatically. So when I go to the toUniversal string method, you can also see that we have explicitly used this dot hour, this dot minute, and this dot second. These are all equivalent to me simply saying hour, minute, and second. If I just use the name of an instance variable, the compiler looks within the definition of this method to see if that variable is defined here. If it's not a local variable, and therefore it goes out to the class's scope and looks for the definition of it at class scope. So when I say this dot hour down in line 46, it's the exact same thing in this context as using just hour by itself. Same thing for this dot minute and this dot second. I can explicitly use the this reference as I've done here, but I don't have to because there's no naming conflict in this context between the instance variable name and a parameter. In this case, we have no parameters for this particular method. Now, one of the things that's interesting about using this dot explicitly, and I'm going to cut this out for a moment just to demonstrate, is if I type this and a dot, I get IntelliSense support showing me all the members of the current class that are allowed to be used right at that point in the code, in that context. So not only do you see things like the build string method, and if I scroll down, the toUniversal string method that are defined within this class, you also see the private data members as indicated with these blue icons with the locks on them called hour, minute, and second, as well as all the other things that are being inherited as part of our new class definition from the class object. And remember, things like the toString method are available in every single class you ever define. So even though our class SimpleTime does not explicitly define toString, I can see here in my IntelliSense window that there is a toString method that I could call explicitly if I wanted to in this context. It won't give me the same string representation that we introduced in a prior example, but it will give me some sort of string representation for the object. So given that I've typed this dot, I can then go scroll through this list. I'm using the wheel on my mouse at the moment, and I can select the particular member that I'd like to call or access. I'll double click toUniversal string in this case and put back in the parentheses to complete the method call. So what you're seeing within class SimpleTime here are a couple of common ways in which you can explicitly use the this reference to access members of the current class, and on an object by object basis, this always represents the current object. So when I go back up to main here, when this new simple time object is created, within the object being created, this is referring to specifically the new simple time object that's being created on line 9. If I were to go create a second simple time object while that object's being manipulated, this would refer to that other object. In line 10, when I say time.buildString, that means that this is referring to the time object. If I had some other object named time2 and I called a method on that object, then this would be referring to the other object. So this is all handled for you underneath the hood. You don't actually have to declare this reference. It's just automatically available to you inside the body of every non-static method and property of your class.